Venus, Earth's hotter sister. Venus's atmosphere consists mainly of carbon dioxide, with clouds of sulfuric acid droplets. The thick atmosphere traps the sun's heat, resulting in surface temperatures higher than 880 degrees Fahrenheit, or 470 degrees Celsius. The atmosphere has many layers with different temperatures. At the level where the clouds are, about 30 miles up from the surface, it's about the same temperature as on the surface of Earth. As Venus moves forward in its solar orbit while slowly rotating backwards on its axis, the top level of clouds zips around the planet every 4 Earth days, driven by hurricane-force winds traveling at about 224 miles per hour, or 360 kilometers per hour. Atmospheric lightning bursts light up these quick-moving clouds. Speeds within the clouds decrease the cloud height, and at the surface are estimated to be just a few miles per hour. On the ground, it would look like a very hazy, overcast day on Earth, and the atmosphere is so heavy it would feel like you were 1 mile deep underwater. With a radius of 3,760 miles, or 6,052 kilometers, Venus is roughly the same size as Earth, just slightly smaller. Because of this, it is often referred to as the Earth's sister. From an average distance of 67 million miles, or 108 million kilometers, Venus is 0.7 astronomical units away from the Sun. 1 astronomical unit is the distance from the Sun to the Earth. From this distance, it takes sunlight 6 minutes to travel from the Sun to Venus. Its highest mountain is Maxwell Montes, at 20,000 feet high. And oddly enough, Venus spins the exact opposite way as Earth does. No human has ever visited Venus, but the spacecraft that have been sent to the alien surface do not last very long there. Venus's high surface temperature overheats electronics in spacecraft in such a short time, so it seems unlikely that a person could survive for long on this planet's surface. Upon close examination, the rocks are different shades of gray, like those on Earth, but the thick atmosphere filters the sunlight so that everything would look orange if you were standing on the planet's surface. It is thought that Venus was completely resurfaced by volcanic activity 300 to 500 million years ago. The planet has 2 large highland areas, Ishtar Terra, about the size of Australia in the northern polar region, and Aphrodite Terra, about the size of South America, straddling the equator and extending for almost 6,000 miles, or 10,000 kilometers. From space, Venus is bright white because it is covered with clouds that reflect and scatter sunlight. At the surface, it looks like a pearl. Exploration of Venus's surface is very challenging due to the harsh atmospheric conditions and high temperatures. The surface temperature of Venus is 450 degrees Celsius to 500 degrees Celsius. Therefore, if there were a space probe designed using conventional technologies, it would be destroyed above 200 degrees Celsius, and there cannot be any reliable results for the mission to explore the planet. There needs to be a probe that can survive and be able to give stable and reliable results by enduring high temperature for long operational time. Many attempts were made to explore Venus by the last 2 decades, but unfortunately these attempts have never gained much success. Our task now is to study the harsh environment and also operation of electronic devices, such as environments, to include and introduce better materials or techniques that can help in stable and reliable operation of that kind of device in the future. In 2017, NASA's Glenn Research Center introduced a technology that can open new paths for Venus exploration in the future. Such electronics could drastically improve Venus's lander designs and mission concepts, enabling the first long-duration missions to the surface. Venus is from one of the 4 terrestrial planets in the solar system and is the second planet from the Sun. In comparison of other planets, it completes 1 round trip in longer time and also in the opposite direction to many other planets. After the Moon, it is the brightest object in the sky. The atmosphere of Venus is very challenging and invites scientists to conduct surface exploration. It is comprised of approximately 96.5% of carbon dioxide, 3.5% of nitrogen, and traces of sulfur dioxide, hydrochloric acid, and hydrofluoric acid. In comparison to Earth, the atmosphere of Venus is thicker and nitrogen contents are almost 4 times higher than that of Earth. Venus's clouds, which are composed of sulfur dioxide gas and droplets of sulfuric acid, the thickest layer of this cloud exists within the troposphere, approximately 48 kilometers above the surface. Venera 3 was the first spacecraft that crash-landed on Venus in 1966. Its predecessor, Venera 2, failed due to overheating shortly after completion of its mission. And it was the sister craft of the next version, which landed successfully. In 1967, Venera 4 was successful to return measurements taken directly from the planet's surface. Later on in 1969, the results were verified by Venera 5 and Venera 6. And also in 1970, Venera 7 managed to stay on Venus's surface for only 23 minutes due to the intolerance for high temperature. Despite previous failures and a focus by NASA and other agencies to populate Mars, we should still leave some attention towards Venus and let our imaginations flow with the possibility of one day populating our sister planet.
Be sure to subscribe for more Space Rewind and tell us in the comments what you would like to see next in an upcoming video.